Okay, in 8.3 part 1 we talked about the integral test, which is not always the most fun one to do. So this one's a little bit better. It's a break from the difficulty, and this is one where you're going to be able to just look at the series and really quickly, once you learn it, decide does this thing converge or diverge. This particular series is called a P-series. So today we're in purple for P-series. And so if you just expand this out a little bit to get an idea of what it would look like, when n is 1, you get 1 over 1 to the p. When n is 2, you get 1 over 2 to the p, 1 over 3 to the p, and so on. So remember, we're trying to decide which ones of these infinite series converge and add up infinity terms, add up to a finite amount, and which ones diverge, meaning they will eventually add up to infinity. There's no ceiling on how high they will add. Just as a side note, let's talk about geometrics for 1 minute. I'm going to call this section the fine line between infinity and finite. Okay, what I mean by that is there are series that are very close to each other that one of them adds up to infinity and the next one does not. For example, if I start with the number 1 and I add to that, multiply by 0.99, let's say, and then I multiply by 0.99 squared, or by 0.99 again. So if the terms of my series are 1, 0.99, 0.99 squared, 0.99 cubed, this is geometric. All right, its first term is 1. Its common ratio, the number that we multiply by each time, is 0.99. And so I get 1 over 1 minus 0.99 is 0.01, which is 1 over 100th, which is 100. So these terms converge to 100 if I add them up forever. So that r being 0.99, with geometric, anytime the r is a fractional value or value less than 1, then it goes to infinity. If I had the same setup, and I started with 1 and I multiplied by 1.01, this thing adds up to infinity because that's geometric with an r value of 1.01. In other words, those terms are not approaching 0. Those terms are diverging. So therefore, the series diverges. Any geometric whose r value is not between minus 1 and 1, not including minus 1 and 1, diverges. So 0.99 and 1.01 are very close to each other, but their sums are very far apart. 100 versus infinity is a big difference. So there's a fine line between convergence and not in geometric. That same fine line is going to happen with what's called a P-series. Okay, so a P-series, I've shown you what it looks like above. Okay, so this is the format for a P-series. And there's a simple rule for a P-series whether or not it's going to converge. Okay, if P is greater than 1, then, which in P is the power of the bottom, or the exponent of the bottom, then it converges. And if P is less than or equal to 1, let me rephrase that. If P is between 0 and 1, including 1, then it diverges. So this becomes a very easy determination of convergence or divergence. You just have to recognize that it's a P-series, see what P is, and then follow this simple test. And this has a very fine line as well, and that fine line happens at 1. If you're having trouble remembering this, just think of these are bigger p's. And bigger p's being on the bottom, bigger numbers on the bottom or on the denominator means smaller values. So if you have a larger value on the bottom, that's a smaller value overall, and smaller values are more likely to converge than larger values. So that little hint in red is just to help you sort out. If you remember that the cutoff is 1, but you can't remember which one is which, just remember larger values on the bottom means smaller values, which mean that's more likely to converge. So anyway, just a couple of examples. If I give you the sum, as n goes from 1 to infinity, of 1 over n squared. Okay, this is definitely a p-series. It fits perfectly into the mold. It would be 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared, and so on. So that would be 1 plus a fourth plus a ninth. Those terms are approaching 0. They always get smaller and smaller. And since it's a p-series and we can tell that p is equal to 2, that's it. P is greater than 1. So my rationale for this answer, if I gave you this on a quiz or a test, you would say p-series, p is greater than 1, or you could say p is equal to 2, same thing, converges. Now, don't overstate this. We don't know what it converges to. Remember that the only ones we can actually add up are the geometric and the telescoping. I know that this converges, but I do not know what that limit is. If I add 1 plus a fourth plus a ninth plus a 16th plus a 1/25th, there's a certain level that I will never go over. I don't know what that level is, but I know it's there. So I can just say convergence. All right, another quick one. What about from 1 to infinity of 1 over the square root of n? So it won't always look perfectly like the pattern, but you just need to realize that the square root of n is a 1/2 power. So you don't even have to write out any terms. This is a p-series. P is equal to a half, which is less than 1, less than or equal to 1, and bigger than or equal to 0. So this diverges. Again, you've got smaller values for your p, which means smaller values on the bottom, which means bigger values overall, and bigger values are more likely to diverge. So that is almost it. I just want to talk about the fine line real quick. This is called the harmonic series. And by definition, the harmonic series is a p-series when p equals 1, that cutoff point. I know that if it equals 1, according to my rule, that I'm going to diverge right here. Less than or equal to 1 is divergence. So this 1 is the cutoff point. If I go greater than 1, I converge. If I am 1 or less, I diverge. So the harmonic series just looks like 1 over n. So it's 1 plus a half plus a third plus a fourth, and so on. So by rule, this thing diverges, but it's by far the most common p-series. It's when p is 1, it's just 1 plus a half plus a third, and it's called harmonic. I know we have a few musicians in class. Some of you could probably tell us about harmonics and how this is related to music. There's a little note about it in your book. I don't understand all that, but I know that it has connections to music, so that might interest some of you. But the harmonic series diverges. A common thing is for people to look at this harmonic series and say the terms are going to 0, it converges. But remember, that's the nth term test. The terms go to 0, so it has a chance to converge, but the harmonic series diverges because it's a p-series when p equals 1. So update your Venn diagram. I'm not going to pull it up right now, but pull up your Venn diagram from the first day of 8. 0.2 and add a p-series for p is greater than 1 to the converges side, and a p-series p between 0 and 1, including 1, onto the diverge side. All right? So that's two parts of this section. We've got integral test and p-series. P-series are really quick once you recognize it. The integral ones take a little bit of time, but that concludes section 3. All right, so make sure you are keeping up with your geometry and your rules of craps assignments, and then we will get to working on 8.3 in class. I will see you then. Young out.